Hi everyone, welcome to adding and subtracting rational functions. Go ahead, let's label these notes. 7.4. So as a reminder, feel free to pause this video, copy down everything on the screen, make sure that you're taking your time with it. It's for you to use. So once again, when I'm starting with these rational functions, I'm going to start with a fraction that we already know. So I'm going to take 5 over 2 and I'm going to add 1/3 to it. Now we know right away that I cannot just go ahead and add these together. Before I add fractions, we need to create like denominators. So my 5 over 2, I need to multiply by 3 over 3. And my 1/3, I need to multiply by 2 over 2. Now, this creates the like denominator of 6. So I have 15 over 6 plus 2 over 6. Now I can add the numerators and I get my final answer of 17 over 6. So we're going to use all of those steps that we just did with our rational functions. And we're going to jump right into example 1. So with example 1, I have 1 over 3x plus x over 3x squared minus 12x. Now, we can't quite see what my denominator's factors are, and in order to do that, we need to make sure that we are factoring our denominators. So I'm going to go ahead and write our steps on the side. And step number 1 is to factor denominators. So I'm going to go back to my first fraction, and I can't factor anything here. I have 1 over 3x. That's as simple as it can go. It's a monomial. However, on the other side, I have a GCF, and I have the GCF of 3x. So 3x minus 4. So as we can see here, I have a 3x and a 3x. However, I am missing an x minus 4 from the other side of my fraction. So I am going to need to multiply my other fraction by x minus 4 over x minus 4. That way, my denominator is going to be 3x times x minus 4. And that's going to be the same on both. This one I'm going to multiply my numerator too. This one on the right side does not change. Okay, now that I have the same denominators, I can go ahead and I can add up our numerators. So I simply just have 2 x's here, and then I'm subtracting 4. That constant can't combine with anything, and I'm going to keep my denominator in factored form just so that I can see the domain there. I know that x cannot be 4 and it cannot be 0. So going back to my steps on the other side is that we factored the denominators, and then after we factored the denominators, we created like denominators by multiplying by missing factors. After we did that, we went ahead and we added our numerators. So added the numerators together. Now step number 4 here, and I'm going to go ahead and say step number 4 if necessary, so I'm going to put a little star next to it, is you're going to go ahead and you would simplify if needed. So in our example that we have right here, there's nothing that's going to cancel out. I could factor out a 2, however, that's not going to be helpful in canceling anything from the denominator or the numerator. So I'm going to go ahead, I'm going to move on to example 2 just so that we can see another one in action. I'm going to go a little bit faster, so once again, if you need to pause, feel free to. So example 2 here, I'm going to have x over x squared minus x minus 12 minus 5 over 12x minus 48. All right, so step number 1, I need to factor my denominators. So when I factor this first one, I have x minus 4 times x plus 3 minus 5 over 12 times x minus 4. And I'm going to use my highlighter here. And I'm going to show that I have an x minus 4 and an x minus 4. Okay, so both of the denominators have an x minus 4. However, this one has an x minus 3, and this one over here has a 12. So I'm going to need to multiply my left one by 12 over 12 because it's missing from that side. And the one on the right, I'm going to need to multiply by x plus 3 over x plus 3. So that my new denominators are 12 times x minus 4, x plus 3, and I'm going to end up just writing my other denominator here so that I know that I'm using like denominators for both. And then I'm going to go back to my numerators and multiply everything out. I'm going to keep parentheses around this one because we're subtracting, and I really want to watch my signs here. Okay, so I factored my denominators, I created like denominators, I now need to combine my numerators. So this side, I have 12x minus 5x, so I have 7x, and then a minus 15. Watch out on that minus because you end up subtracting there. And then my denominator is 12x minus 4 times x plus 3. And I can't factor anything, so that's as simple as it's going to get. Final answer. Why don't you try one on your own? So I'm going to say you try. Once you copy down the problem, I'd really like you to pause the video and try it by yourself. 3 over 4x minus 1 over 7. Go for it, pause the video, try it, and come on back. Okay, so I need to multiply this side by 4x over 4x. I need to multiply this side by 7 over 7. This ends up being 21 over 28x minus 4x over 28x, meaning that we have 21 minus 4x over 28x. Or maybe you write it like this, negative 4x plus 21 over 28x, because you wanted to keep your x's up front. Either one, totally fine. We have one more concept that we need to go over. So I'm going to go ahead, I'm going to label this as complex fractions. And these are not as tricky as what they look. They look kind of tricky. However, we just need to remember our order of operations. So we're starting with 3 over x plus 5 over 2 times x minus 3 plus 1 over x plus 5. Now the thing that we really need to go ahead and we need to remember, and I'm going to star this right here, remember PEMDAS. So here's the thing, is that this, this fraction bar right here is a fancy way of saying divide. So this actually means 3 over x plus 5 divided by 2 over x minus 3 plus 1 over x plus 5. Okay, so this we can definitely do. This is going back to section 7.3 and dividing. But before we do that, we need to combine our complex fractions here by adding them. So I'm going to create a like denominator, meaning that I need to multiply this guy over here, x plus 5, and I need to multiply this one by x minus 3. Now I'm going to show you a little bit of a trick here, and if you don't like this, you definitely don't have to use it. But some people like to go ahead and write their numerator as one numerator, their denominator as one denominator, and then all of their terms up on the top. So this one actually we're going to distribute at the same time. I'm going to do 2x plus 10, we lost our bar here, plus x minus 3. Now we can just go ahead and combine those like terms. So this one ends up being 3x plus 7 over x minus 3, x plus 5. Now if we remember from 7.3, is that this divide sign simply just means that we need to go ahead and change it into multiplication. So 3 over x plus 5 times, now I need to flip these, x minus 3, x plus 5, all over 3x plus 7. We see here that I have an x plus 5, meaning that my final answer is 3 times x minus 3 over 3x plus 7. Now, I got rid of that 5, so I know that x cannot be negative 5. We can't forget about our domains. However, what I need you to do is look at the screen right now. This is super important. We're also going to say that x cannot be 3. And that's because when I go back up here to the top in my original problem right here, x minus 3, meaning that if I plug in 3 for that problem, I would get 0 as a denominator, and that is a big no-no. So we need to make sure that if at any point a denominator equals 0, I cannot use that number. And that's in my original problem, so x cannot be 3. Why don't you go ahead? I'm going to go ahead and put this in blue. I have one more for you to try. So you try. You know how it works by now. Go ahead, pause. We're going to do 2 over x minus 4 all over 2 over x plus 3. Go for it. Hit pause. Try it on your own. Okay, so what we're going to need to do first is I'm going to rewrite this. And I'm going to put some parentheses around this because now we're dividing 2 over x plus 3. First thing that I need to do is that I'm going to multiply this guy by x over x and my 3 by x over x, meaning that I am going to get 2 minus 4x all over x divided by 2 plus 3x all over x. Let's change this to multiplication times x over 2 plus 3x. I'm going to cancel out an x, cancel out an x. I have 2 minus 4x all over 2 plus 3x. If you wanted to go ahead and factor, you could if you wanted to, meaning that you might have 2 times 1 minus 2x over 2 plus 3x. However, we definitely know that x cannot be 0 because it was right here in our original problem as a denominator of 0. Great job.